know the definition of groups and some examples. Today also we are going to see one example. So the question is, let G denote the set of all matrices of the form X, 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 where X belongs to R star. Now we are going to prove that G is the group under matrix multiplication. So what are all given? So given, let A be the matrix, a 2 by 2 matrix X, 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 which belongs to R star. Here I am going to take one more element B. So B is equal to Y, Y and Y, Y. So for proving the theorem to be a group, so first one you have to say it is a closure. Second one, it should satisfy associative. And third condition, it should satisfy identity. And the last one, inverse. So if it satisfies all these four conditions, then we say that G is a group. So let me solve the first one, closure property. So closure property is nothing but if A comma B belongs to G, then A star B also belongs to G. So I am having A and B here. So let me find A star B. So A star B is equal to XX and XX into YY and YY. That is, you have to multiply these two 2 by 2 matrix. So the answer will be a 2 by 2 matrix. What you get? So when you multiply X into Y, you get XY. Similarly, plus X into Y, XY. Same thing only come in the next column also. So XY plus XY and XY plus XY, XY plus XY. So the answer is 2XY. So which is also belongs to R star. Therefore, G is closed. Here, first condition is satisfied. And second one is associative. So associative is nothing but you have to take any three elements A, B, C. Suppose if you have A, comma B, comma C belongs to that group G, then the condition is A star B star C is equal to A star B star C. So always matrix multiplication is associative, so no need to prove this. So this is enough. Let me prove the third condition. So third one is identity. So identity is nothing but if an element, if A belongs to G, similarly E also belongs to G, then what is the condition? A star E equal to E star A equal to A. So from this condition we are going to find our identity element. What is A star A? A is nothing but X, 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 and E, let me take it as all the elements to be the identity element, equal to again A. A is nothing but X, 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 X. So this is nothing but when you multiply this you get Xe plus Xe, that is 2Xe. Similarly here also 2Xe and 2Xe and 2Xe. On the right hand side we are having X, 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 X. So here when you equate this 2Xe equal to X, so X gets cancelled. So 2E is equal to 1 or E is equal to 1 by 2. So our identity element E is 1 by 2. When you substitute here, you get the identity matrix E to be 1 by 2, 1 by 2, 1 by 2 and 1 by 2. So this is our identity matrix E. So the last condition, inverse. So the fourth one is inverse. So inverse is nothing but we all know A star A inverse equal to A inverse star A is equal to E. So here I am going to multiply A equal to XX, XX, and A inverse is nothing but let me take it as YY, YY, and E is nothing but our identity element, that is 1 by 2, 1 by 2, 1 by 2, 1 by 2. So when you multiply this you get 2xy, 2xy, 2xy and 2xy is equal to 1 by 2. So when you equate, you get 2xy equal to 1 by 2, or you get y is equal to 1 by 4x. So this is our y. When you substitute here, you get the A inverse value to be 1 by 4x, 1 by 4x, 1 by 4x and 1 by 4x. So this group G satisfies all the four conditions, hence this is a group.